In today's lesson, we try to look at the way of proving a given distribution function is a probability function. So, if, for example, this is my f of x, which is the distribution function for the uh, event of x, then my f of x will define a probability function if the area under it all the way from minus infinity to infinity is equal to 1, and that is equal to a probability of 100%. So all we need to do then to show that this area is equal to 1, area of the um, distribution function all the way from minus infinity to infinity. As an example, prove that for all values of k greater than 0, a density function as below can be a probability distribution function. So here we have our f of x, which gives the probability for any given value of x. If x is less than 0, that probability is 0, and if x is 0 or greater, then the value of f of x is given by 1 on k times e to the power of minus x on k. So that is our function, and we want to show that area under this all the way from minus infinity to infinity is equal to 1. Alright, so we form the integration and we split it into two parts because our function itself is given in two parts. One from minus infinity to 0, which is x less than 0, and the other one is x0 or positive. So I split the whole values of from minus infinity to infinity into minus infinity to 0 and then 0 to infinity and then integrated. Alright, substituting for f of x, when x is between minus infinity and 0, it's just 0, and f of x is 1 on k e to the minus x on k for values of x from 0 to infinity. Integrating that, integral of 0 is a constant value like c, and the integral of an exponential function like e to the minus x on k is e to the minus x on k over minus 1 on k, which is the coefficient of x. And also we had 1 on k, which we need to times. So when you got c from 0 to infinity, c in both cases we have c minus c, which is 0. And for this 1 on k and minus 1 on k cancel out, only negative sign stays. So negative e to the minus x on k. Now if we substitute here, if I have infinity for x, so that's going to be e to the power of a large negative value. Remember that k also is positive. Infinity over k again is going to be infinity, and this negative makes it negative, so it becomes e to the minus infinity, and e to the minus infinity is 0. So the top value of that is going to be 0, and we substitute 0 for x, we get minus e to the power of minus 0 on k, which is e to the 0, which is 1. So then minus 1, and the final result is equal to 1, because these are all 0 and minus 1 is just 1. So we showed that f of x as defined by this rule is a probability distribution function. Thank you for your attention.